Hello. It is time. Okay. So, I've been thinking about it. I was also just doing the thing again where I'm like moving my legs and I'm like, okay, how am I moving my legs? What am I doing to move my legs? What do I think about? Like if I say even the answer is kind of answered by the question itself. What position do I want to put my leg into? Like if I want to arbitrarily move my leg, I think about where do I want it to be? I'm not thinking like I might say like I want to lift my knee so that my like what is that part? I guess on the yeah, I guess that's your femur. So my femur is like level, right? That's what I think about. I think about the final position. And I get there and pretty much I let it kind of stop, right? I'm lifting my leg right now, you can't see. But I need to turn the sound down, I forgot. Hi, Dana. Put your leg between my legs. That sounds like that would hurt. But essentially the whole concept is, even when walking, my thought is, I just need to lift my foot high enough off the ground, and then like let my body fall forward. And then I kind of release my leg and let it fall down. So I think a big part of this that I'm missing, and is not exactly going to be solved by how I determine the response. Like maybe this can be helpful to tune what happens when it's near the end state, or how quickly it will approach that state. Does it slow down as it gets there? That kind of stuff. So maybe this is like really fine-tuning the start and the end of the response. Or maybe like the start, the middle, and the end of travel to the target. But ultimately, it's not like saying, I'm never saying, all right, to get my leg, to lift my leg, I think about lifting it a centimeter, and then I lift it another centimeter. Like, I'm not doing that. That's kind of what I've programmed. Is the response is always like, okay, I'm here and I want to be 1 centimeter over here. And it's like, all right, now I'm there. Now I want to be 1 centimeter over there. That's kind of how I'm programming it. And then I mentioned when the leg falls. So there's not really like, I want to put my leg in this spot. I mean, it's sort of like that. Generally, it's, I want my leg to be, okay, if I think about, if I consider that the position that the leg is going to be in when it lands is going to be the safe location, and it's always possible that it could be near a non-safe location, like if we're on a thin platform, and it's really important that I actually land very, very close to where I want it to land and not too far away from that. Otherwise the leg slips and I'm not on the platform. But then it's also like, well, okay, so what if I do miss? Well, technically there's recovery for that. It detects the leg is too far away and says, okay, we need to bring this leg back. And I guess in theory from a slip, if we come back in the correct way, we should generally be overshooting a little bit, which means if it slips and it comes back, it's going to overshoot and land in a safer place, probably. Even if it was on the same target, it could overshoot a little bit, and that would save it there. I guess if I get into a situation where that's happening too much, then maybe I say, all right, well, if we missed, let's, I don't know, there's like a precision or something, right? And that precision slows it down. The average millionaire is 7 years old? What? Okay, that's crazy. You just threw me off. Anyway, the leg landing is kind of its own thing, and I think the major part of this is that I'm not supposed to be giving on either side The motors do not do well with small, fine adjustments. If I want them to move fast, they don't do well with fine adjustment. And the leg is also technically not doing fine adjustments either. The leg is saying, I want to lift. Okay, where do I lift to? I lift to here. All right, now I want to land. Where do I land? I land there. It's like a it's like a two pose. In fact, it's more like a one pose. There's the lifted pose, and then everything else after that is traveling to, and then traveling from the ground to the air to the ground. Whatever I decide that middle pose to be, it needs to interpolate out of that when landing, interpolate into it when lifting. So really I can kind of set the pose to whatever I want. If I want the crawler to walk with its legs folding in, let me try to model it. Its legs folding in like that. I model this pose. It travels to this pose and then out of that pose. If I want it to flip out when it walks, that's what I do. I model this pose, it travels into this pose and then out of this pose. And technically it can go further where I can say, all right, let's say multiple poses. Let's say we travel to this pose, hold it for some time, travel to this pose, hold it for some time, and then we're done, right? If I say I want to model an animation, or I don't know, some kind of idle thing where the crawler just sits there and lifts its legs to rotate and rotate back. I mean, really, I guess it's not really that, but if I wanted to sit still, I mean, even if I wanted to turn, the turning part is easy. I just make it turn, and the legs will fix for that. But if I say just standing still and I just simply want to model something with the legs, then I say, all right, here's your two poses, go to those poses, right? And then the crawler will do that. So it's not about doing an IK, a very slow transform. I mean, it's good for like a procedural animation where there's no physical objects involved and the pieces can be exactly where I want them to be at any moment in time. But this is now in physics where the modeling part is more about tuning these responses a little bit. Maybe like as this is like a fine-tuning thing perhaps, but ultimately it's about what's the pose? Okay, we need to go to the pose. If I have any in-between poses, then I can say, all right, let's make some in-between poses. But those would be like weak poses or something, where I wouldn't hold that pose and I would just kind of travel through it. It doesn't really matter how close I got to it. I just like try to get there, and then once I'm past that point, then I say, all right, let's go to the real pose that we're going to hold. And I guess in this case, the only hold pose is the grounded pose. Right. Let me check. I don't think I have. I think I just sent everything. So. Wait, why are there? Huh? I thought I sent everything. Well, that's weird. I'm kind of getting hung up on, like, I want to be able to travel a small distance and be fine. That's not really my goal, right? My goal is I want to have some authorship on how it looks when it walks, and most of that just comes from saying, let's go to this place. Okay, let's go out of this place. I didn't watch my cousin's video. Yeah, I didn't. I opened it, and then Instagram was like, log in to see more. And I'm like, okay. So I looked at like the sliver of the video I can see behind that. It really just wants that 5 to be a 7 for some reason. Crazy. Okay. So I want to try to get that. Now, I guess the first question is, the best question to answer first is, how do I want to author what it looks like when it walks? A lot of the stuff here is kind of about when it's deciding to take that step. So I guess none of that should really matter. In fact, it's really important that I don't care about when it chooses to take a step. I just want to say, roughly, what do you do when you try to take a step? This kind of has an effect on it. Well, not really. It's more like that first step and like where its legs are going to be in general while it's moving. Okay. So I just have this style where I have a leg lift height and a swing amount. How much control do I want? I guess it's more about sort of I can think of like a curve where I have perhaps a swing I guess well, I guess there's kind of two things to think about. I think about a curve for the lift height. So from effectively ground to ground, where and 0 being ground, 1 being the target lift height. Or I guess, yeah, the lift height. How do I want it to lift his leg through that? That one is really simple to me. That one's just going to be like a point here and then a smooth curve, ideally. And then I think about maybe the swing amount isn't really a curve, just a flat number that I define. But then I want a curve that says how close or how far from the body do I want the end of the leg to be during that step. So does it tuck in when it takes a step? Does it go out when it takes a step? Or does it stay the same distance the whole time? And by stay the same distance, I mean stay that swing distance. So if I have one swing, then it's going to try to only rotate the leg. If it's no swing, it's going to go in a straight line, so it's going to maintain that distance. Or, I mean, I say maintain distance. Interpolating between a plane representing the middle of the body, this pointed leg stays the same distance from that plane, or interpolating to a point on the body where I say the leg stays the same distance from this point as it moves. Lame, devs being fired from Xbox because they allowed the toxic positivity and now they cry that they are getting fired. Who? What? Source? Source me? Please? I've only heard toxic positivity be mentioned by like a couple people in the industry. One of them being okay, I can't remember who the second one is, but the first one is, I think, someone who worked on Outer Wilds. Yeah, I think like a big guy at Outer Wilds. One? What? Crazy way to write that. I don't know why you're trying to be like encrypt the word. What was the second one? Because the first time I heard it was this guy who was talking about his experience, like, as development continued. Like, it got to a point where you just like couldn't ask anyone to do anything anymore because people were gonna freak out and lose their mind if they were told what to do at their job. Or no. It was more like if people were gonna freak out if they were held accountable for what they were supposed to be doing at their job. Like he was saying, if it's not otherwise, then whatever it is, I'm wrong. But this part should be correct. He was saying that there used to be a board, like an actual board somewhere in the office that said, here's the bugs, and they would put names next to people who were going to work on the bug. Eventually they stopped doing that because people were saying, if I see my name on that list, I'm quitting. I'm going to quit if you put my name on the bug hunting list. It's like, what? It wasn't that they didn't want to do it. They didn't want people to know that they were supposed to be working on it. It was weird. It was a weird thing. And then he was saying that during like gameplay discussions about like what the gameplay should be, he was told that he needs to like be quiet while he's having discussions because people were worried that like work was being done, I guess. That people were actually talking to each other. Silly stuff like that. And then the second one, I don't remember who. I think it was like, it must have just been some YouTubers talking about the game industry in general, and they said like, this person was saying that toxic positivity is a problem. I've only heard it a couple times. It's definitely the kind of thing that people who like are working there know about it, but then no one wants to talk about it. So you saying being fired because they allowed the toxic positivity, I would love to know if that was said by anyone. Or if you're just saying it. Same thing happened in Cyberpunk. Those dang HR guys. Okay, so if that's what I want to have a curve. But it's not only that, it's more like I may want I feel like I specifically want to say a pose. Okay, well, a walk is something different than just a pose. If I think about... Sorry. Oh, man. If I think about walking, there's sort of like a context there where it could just be a curve. And I could specify like a bake interval and say, here's the middle pose, and or this whole sequence is like a weak sequence. Yeah, let me think about this. So I have like a weak and a strong pose. A strong pose is something that I want to get to and stay at some amount of time. I need to get there and stay there before I can continue. Or I give up and I just end the sequence and go back to like a stand. And then there's like a weak pose where I don't really care how close I get to it as long as I'm trying to get there. Because if I think about walking normally, sometimes you can trip because you didn't lift your foot enough, right? So it's sort of like that. A walk is a very weak sequence. It's like during the walk, I just need to like lift the leg. I have some amount of some like try that I'm trying to do, right? Like I want to be roughly this high. If I go higher or lower, I don't exactly care as long as I get close to that. And that's kind of the thing where if anything bad happens during that, there needs to be a recovery. An impact happens. I try to go for the leg land and I miss, and I never actually make contact with the ground, or I do make contact with the ground, but it's not a good slope, or I straight up don't make contact with the ground, but I reach the end, and then I would know at that point that I'm out of the comfort area because I'm not grounded, and I'm not in the comfort zone. So I would say, all right, well, that comes to a decision of deciding to return the leg to some position, or there's a decision to be made there. But I guess what I need to do here is I'm just talking myself in circles, but I gotta think about it out loud. So a weak and a strong sequence. I think that is a real concept. If I think like I'm trying to do martial arts, okay, really those are also probably kind of weak sequences, like in terms of like if you've practiced and trained, you kind of know what you're doing. But it's also like I'm thinking more in terms of a very deliberate, precise action. I want to lift my leg and hold it there for a moment. I want to land in a very particular place because I previously missed the ground, and I'm sure there's ground here. I'm sure there's good ground here. I just have to like be very accurate about placing my foot. Like those are probably more about what a strong concept is. There's no sequence. It's more about being slow and getting very close. I guess that's the parameter then. It's more like I have the pose and then I tune for how close I want to get to that pose. Did I just say that? How fast I want to get to the pose. How close I need to be before I can continue. Or how close I need to stay, rather. And perhaps there is some sort of there's some parameterization here, I think, where maybe it really is like a detachment from IK to physics. So if I say I want to do something, I say, all right, pop the IK into the position of the current leg. Now I start traveling at some rate away from that. And I just say, all right, once I get close enough, I can continue traveling, kind of thing. But it's definitely a thing where it's like the IK will move over time at some rate, some specific speed, to some pose. And it stays there. And then I wait for the physical joints, the physical skeleton to reach or get close to that, and then I say, okay, we've made it. Let's project forward and now go to the next place. And then wait, right? And maybe this kind of models how I'm thinking now about this video about throwing. I can't remember the guy's channel, but he makes really good videos about like, I don't know, like philosophical, but also like scientific stuff. It's a blend. Anyway, the whole idea is that when you try to do something, I think they literally say the the brain essentially projects or produces an action sequence. I mean, I don't know if these are the right terms or whatever. It's kind of blending from reality to simulation here, but some part of the brain produces a sequence of actions. And then your body tries to just follow that, right? It's like, here's the plan, let's go through that. So maybe this is the same idea. I have the plan can probably just be modeled in the same way, where the IK skeleton will sort of travel to its pose at some, probably like ideally like a smooth motion, so it'll start slowly and then ramp up in the middle and then decelerate at the end. Yeah, right. And then the idea is, if you perform the action and the desired result happens well, then congrats. If it does not go well, at this point it gets in more like learning and how is it the what's the I think it's the cerebellum, right? Part of brain for fine motor control. Cerebellum. Okay, I don't... Link. Yeah. So essentially, if you make a mistake, that's kind of like, you know, your brain... This part of the brain is responsible for, like, correcting that. It's like how you train to do something, essentially. Anything physical with your body. But I mean, that part, there's nothing there, really. It's more like just probably some sort of decision logic in there where I say, oh, if I missed it, then what do I do? Do I cancel? Source, let me guess you made it up. What? It was revealed to you by an angel. Cerebellum, not a thing. Yeah. I mean, he had a great flowchart. I don't want to... Okay. It's going to be hard to find it, but I want to find it because I'm talking about it. And I think it's a great video. And I think it's a good channel, too. Ads. I think he talks about it, but there's no it must be just somewhere in here. It's probably here near the end, but I don't even know. Maybe it was some other video that really went over this. Oh well, couldn't see it. Rorn Hub? What is Rorn Hub? Yeah, so I guess what I'm trying to say here is eventually at some point there needs to be some sort of connection between a crawler leg and decision logic based on where the leg is physically. Technically, the leg always knows where it is physically because it obtains the target global position. So this is At this point, it knows the skeleton. It knows what part of its skeleton it cares about most, which is where its foot is. I think generally that's probably how... I mean, I don't know. I like moving my legs around thinking about, like, am I always considering where my leg is or my foot is? Not exactly. Like, I'm doing a motion where I'm, like, bending my like backwards and then just rotating my femur. That I'm not really thinking about where my foot is for that. But I'll say in this case, that's really all it cares about. So it could do some sort of, or not even that. I think there's also a case where the leg needs to know when an impact happens, or I guess maybe that goes to the crawler character knows when an impact happens. I guess then that's more of a question of like where do I organize logic for this versus making AI? Well, yeah. But I think at some point that's definitely a thing where there's a difference between something being overtuned and the leg is moving too fast versus something external has happened and it's not really something that I should tune for. Or maybe something external happens and I say, all right, let's try to freeze the leg. And I think about landing. What exactly does it mean? I think it just means getting roughly to some position and saying, all right, if I release now and I just firmly plant, hopefully I reach the target, I guess, right? And maybe, I mean, I guess there's too many things to think about. On the one hand, I can say the leg can probably keep track of some variable and maybe somehow, I don't even know. Maybe I should look at this other system that's for signal control versus disturbances. A very simple one, which was mentioned, is just saying like a known disturbance, which I guess in this case, an impact is kind of a known disturbance that can happen. And maybe that depends on how strong the impact is. Maybe it depends on where the impact is. If the impact is close to the femur, it's not such a big deal. If it's on the very end of the foot, it's quite a big deal because that is where I guess you have the least control. I guess in terms of like the torque, right? If it's close to a joint and it's in the direction that the joint rotates in, then okay, that's fine. We can control that. If it's far from a joint and it's on an axis that the joint does not control, or sorry, if it's far from a joint on an axis that the joint controls, then it's kind of an issue. So maybe in that case, I might say, hey, the impact happened here, and this impact is in the direction of the femur axis of rotation, or I guess not in the direction of the axis of rotation, but is acting with that axis of rotation. And it's a massive impact. It's caused a lot of movement. This might mean to say, all right, we need to do like a freeze, right? Pause the system, just try to reach target zero velocity on that joint, recover. Once we're close to zero, we can start traveling. We can make a decision about where we want the lake to be and then go there. Right? Definitely a lot more engineering, and still following the trend of me saying this crawler's program like an engineering project and not like some animated character. Also means if I want to do anything weird, I can say I could go in there and like disable certain portions of code and say like, or yes, I say disable. I would turn off sensors in some way. I might say, hey, this joint's received damage, this motor is now non-functional. Okay, how does the system respond to that? That kind of thing. And the ultimate question is, where do I start? I should probably start just by doing a test of traveling opposed to pose travel. And maybe it doesn't matter how I author that. Or I need to be considerate of how I want to author a pose and feed it into this as an input. Be considerate of that, but probably just more focus on trying to make it happen first. And then saying, all right, this works if I send two poses to say lift up and then drop down forward. What happens there? Okay, so I guess the question is then, how do I set up a pose? I have never been arrested for public indecency. Okay. There's some funny implications there on a sentence like that. I have no clue how I want to author a pose. What do I want it to look like in the code? What should a pose look like in the code? I don't know. What control do I have? I guess the only control that I have is where's the target position? Where's the target? So I suppose in that case, it's always going to be moving the target from one position to another position. Right, I have things that I need to probably just send. Right, and this is me trying to figure something out there. Yeah, I think I should go ahead and drop back to velocity and position steps being at 16. Because those are going to be final things, so I need to make sure that if I'm using the tuning of the motor response to essentially be what happens near. Okay. Okay. I'm going to commit to saying that the expectation of the motors is that they need to approach some goal and stabilize near that goal. Not really saying, all right, I need you to travel 1 centimeter. I need you to do it fast. Not that, right? Yeah, I don't know if I finished my sentence, but this was... oh, man. This is a bug. It only happens when I start the project for the first time. It doesn't happen when I reload a scene. It is only when the project loads. And it makes me mad. Because I just know that it's because Godot does stupid stuff with resources on load. Specifically on load. They will load them before scenes, but then place them into the scene before the scene loads they do stupid things with resources. Because they start running code like on project startup before anything is really ready. Even though this stuff is supposed to be applied when the node exists, it's like it runs the code on the resource that's connected to a node that doesn't actually exist yet. I don't know how to explain it. It's weird enough that it only prints that it's only a problem when you start the project and never an issue when you're opening a scene or reloading the scene. It's specifically only on startup. It doesn't happen at runtime either. I click play, the errors don't happen. Literally open the editor, the error happens, and that's the only time it can happen. Because it's just calling methods on resources when they shouldn't be happening. Motor controller. Or yeah, I think I can probably add that too. What? Can we? Oh. Why does femur motor add those things? I guess they were on defaults before. Why do those IDs change? Maybe one day people will figure out how to like program it so IDs don't randomly change like this. Because it looks like that's exactly what's happened. In fact, that ID isn't even used. What's happening? What's happening here? Those point to... Oh, I added a new material, and the ID of an existing material changed. And then things that were using the old material also had to have their ID changed because I added a new material. Yeah, that's actually just insane. I think it's just because they use their paths, right? IDs generate randomly based on, or I say randomly, they generate procedurally based on like the path of the file and the name. And then if it fails, it like runs it again. So it generates a new one, which means this one succeeds. And then this one, for some reason, changes because this is what it would have been But because I added a new one above it, this one takes over that ID, and then this ID changes. Yeah, that's just insane. Maybe you should load in all the IDs, and then when you add a new one, commit to that ID and don't change it, because this is what happened. I added a new one, and went to save it. It just generated a new ID for this one without checking if it existed, if that ID already existed. So then I guess this other one says, oh, we can't use that ID now. So then it changes the ID. Jeez. Silly stuff. Yeah, I mean, it should definitely just be like random number generator ID. And then anytime you load and save a file, you always prioritize existing IDs first. Because it looks like the system doesn't prioritize existing IDs first. It favors the first thing in the list to get the ID. And then they had to go in there and write logic to handle the case where a different ID is overwritten and handle that change. Crazy. All right, so I don't want that to happen. So I'm actually just going to go and clean this up and like delete these meshes that I have. Because that is just crazy. I still have a sphere mesh. Oh. Right, because it changed the existing thing. One of these is using a sphere mesh. Or these meshes are using that now busted up ID. Yeah, it's just kind of crazy. That doesn't make any sense to me. I think there is. Can you just show me? I think I found out. Hatch. So I do -P. Discard, yes. Discard, yes. No. Great. And now those dumb changes are gone. Reload. Is it going to insist on it, though? That's the real question. I guess that did change. Though, where is that? (7WTPE). (7WTPE). And then 7WTP is used all over the place. Of course. Sphere mesh. Uses 7WTP. 76STG. Floor, cylinder mesh. I'm looking for sphere mesh. Ball. The ball? The ball uses that mesh material? Oh. Look at that. Oh yeah, also, I actually didn't even need to do that because the restore should have fixed that. And the restore did fix that, and then I hit save and it wrote back a thing that I should have reloaded from disk. Jeez. What does it even mean then? How do you write a function that's supposed to reload from disk, which doesn't reload from disk? Wait, I might have just realized what this is. Why these decimals do this. I think it's because the most accurate representation of 0.82 as a single precision float is something like a 1 at the end here. There's like a 1 sitting there. And so then it says, all right, well, what's the closest representation of a double precision of that number? Or no, I think it says the float. And the float says, all right, here's how we convert that to a double. Like, this is a very accurate representation of what the closest single precision float could represent. Because the single precision still has, like... Even though a single would, like, place a 1 here, it really represents this number. And so double comes in and says, oh, I can represent that, and here's how close I can get. That's probably why all this stuff is messed up like this. Whereas, like, the last, like, 4 or 5 or 6 digits are just crap constantly. And sometimes they even get locked in. Sometimes they even get locked where they keep fluctuating. Where literally press save and the number changes from like a 9.8 to a 9.7 and just keeps flipping back and forth between those two numbers. Or I guess maybe that's like too accurate, but like a 9 and a 9.5 is like what would happen. These guys are so dumb. I think exactly what it is. They do this crazy floating point hopscotch. We're like, oh, here's the binary for single precision float of this value. And here's like the expanded version of like, if you were to represent that exactly as what the binary really means, then this is the value, which has extra digits. And then the double comes in and says, oh yeah, here's how I would represent that. remember looking at it once and I tried to fix it. I never quite fixed it. I corrected a lot of things, especially where it's like a basis transform just glitches out and says one of the zeros should be like some like small value like e to the negative 17. Like you can't even represent that in this many digits. This isn't even 17 digits. It would be like over here at the end, and that's like a 1. And I also didn't quite fix that. That would still happen sometimes. I still have to manually fix it. And then it wouldn't solve cases where a number gets like super screwed up. Like where these digits come out way too far. Like maybe here this wouldn't be enough 9s and it would say, okay, well, we can't collapse this one, so I save this one. Because yeah, there'd be like 6 messed up digits at the end. Actually, where was one that was like 6? This one has 6 messed up digits. See the news, helium is ending tomorrow? I don't even know what helium is. Okay, well I can add this one. I'm just complaining about the same stuff again. I don't think I want to send any of those. I do want to add that. Normie? Yeah. So I've added this. Actually, do I want to send... I think I probably want to send the bug fix first. These things instead. So yeah, everything from here, go back. And then... that one goes back. I thought I just wrote that. Wait, what did I just do? Hang on. I did. I meant to do get diff stage. Okay, this is everything I want to send. And then I'm adding all of that. Yeah. Then I do think once I get into the posting, I think I might do a double layer, a cascade of these, where I have one that sets the target velocity and one that sets the one that matches the velocity, I guess. So one reads the angle error, produces a velocity. The one reads the velocity and the current velocity as an error and produces an acceleration. Because it's more like that extra piece in there, right? I've added some information to the system, which is the velocity error and not just the angle error. Maybe I should just do that now. Maybe that would help now. What does it look like now before I do this? Yeah, it should like never stabilize really. That does like kind of hit the target though sometimes when it passes by. Um, I just feel like this is an odd response. Like, have I made a mistake there? Because seeing what just happened, do I not just have a mistake? I just closed the tab by accident. Oh, Firefox. Why don't you know exactly what I'm trying to do? It should have known I didn't want to close that. I don't even need this tab anyway. I'm closing it. Okay, let me just copy that. I'm going to paste it in here. That's handled because I set them all to 0. These initialized to 0. Error 2 is error 1. Error 1 is error 0. Error 0 is target minus input. Put this mem 0. Okay. D1 is D0. 5 is 4. And then 4 is A0D plus arrow 0 times that plus that. don't see a mistake. I was going to say there could have been an ordering problem, but I don't think so. There really isn't a mistake here. Okay. Yeah. Couldn't find a mistake in any of that. Yeah. Um, I guess technically I shouldn't like name it this way, should I? It's kind of a bad name. I'll just call it controller. Uh, not there. Here. Well, actually, I guess this one's actually simpler than that. Never mind. I may as well make it a function. And I guess I should do this for everything. Okay. And then, yeah, I think I want to use that all the time. Too few arguments in calculate velocity. Right. So there's the input, the target, the angle, the target angle, and the velocity. Is that why it's negative? No, it's still a weird negative to have. But rotation delta represents the rotation from the pose to where rotation delta represents the change, actually. Yeah. It's from our current, it's from where we were to where we want to be. From to, right? To, from. So it is still weird that it's like a negative result. But oh well. Where's actual velocity? I believe I say that's calculated by the chain. Yeah, set by the chain. Computed velocity of the joint on the rotation axis. Input not declared. Ah, okay. So this calculates a velocity. These are technically all I'm just gonna make a method to copy this over. Maybe this go in a controller. Maybe this should go in controller. That probably makes a lot more sense. Because then this could have control over when this might need to reset something. Okay. Um, let's just try this. Hey, what now? Alright, they don't like to do anything. It's actually really interesting. Why do they not do anything? It's not annoying at all that this keeps closing. Not annoying at all. Honestly, like some of these small things, it really makes me wonder if they... Do they know anybody who works on this? Is there anybody who knows someone who works on it? Tell them about these dumb things. Seeing this jitter back and forth pretty hard there. Yeah, this is where it would probably be nice to have like a visual display of it. What the input is and what the output is. Whoa. That is an extreme value. Present velocity is 2.8. Target velocity is just 0. So we output 500. Okay. So why does that not do anything? Desired motor velocity is now this value, and then we're going to clamp it to the maximum velocity. Eight. That's just insane, though. We want to be 0, so we output... It's not velocity, I'm outputting a change in velocity. That's absurd. Okay, so derivative is crazy. Sorry. There's just something flying around. I think it is just supposed to be velocity passing it through again. Okay, so derivative way too high. Still too high. Then. How does that make any sense? Our current velocity is negative 0.83. Our target is 0. And it's like, okay, let's go to negative 12. How does that make any sense? So what's memory right now? So I see a crazy value at 4 and 5. In fact, they both just have... Yeah, they both have the opposite sign. So I've calculated a new output, which is to be negative 3, because we were at negative 12. So our new output is to be negative 3. Just going to calculate some values. We're going to shift 4 into 5. And then calculate a new 4. New 4 is negative. I mean, that's just such a dramatic change. Derivative too low. Five. Jeez. Some absurd values. I should have looked at what the output was last time before I stepped over that. Whoops. Okay. Derivative is supposed to be like in seconds, which I would think means it's making like smaller adjustments, right? A larger value here means a larger value here. That just makes these values larger. When I make that one larger, this one becomes larger. And this is nothing. Unrelated. So it really is just, I should be using a smaller value. $458 was the previous output. Jeez. Shift everything. And I had a small error there. The current error, the previous error, and then the third previous error. $458 to what? Exactly the same value. Oh, it is the previous output plus that. Right, so if the previous output's really high, then it's going to stay high for a while. Is that the case? So 458, it basically didn't change. That did not change because these are like A0 plus A, or error plus the previous error times 0 and 1. Is this really correct? Because this is the case where if I don't have anything on the eye, then it doesn't work. It doesn't do anything. Because its output would always be to just do nothing. The error doesn't change, so it doesn't do anything. I need to have an eye. And then derivative, I assume, also can't do anything if the errors aren't changing. Okay. They did say I could use it as an inverse. So I could do ki over delta. So that means if I say 1, then... Oh, I guess this is more like a change applied over a second. So it's actually wrong. This is not an inverse. It is actually wrong about that. This is actually a timing value. If I say 1, then that means 1 second. Well, maybe. I don't know. It's strange. If I say a small value, that kind of means like 0.5 over 1, so it'd be like 2 seconds to accumulate. 2 would mean a half second to accumulate. Either way I do it, 1 is going to be the same, unless I put the division here exactly on the spot. Then it's actually very different. Let me start it over, because that just has such an insane error that it's just kind of not possible for it to recover within like the next 5 minutes. Like that's how bad that is. Yeah, I see it flicking. Yeah. Four and 5 are just massive again. And the previous output's 15. Input 3, output 0, and it should I just always clear it to the current output? Should I just always do this? I feel like I really want to. Input is 2, target is 0, and it's like, oh yeah, but my last output was -14, which means there was an overshoot. Does it just mean proportional is too high? What does that mean? I mean, maybe it does mean proportional is just way too high. Wrong thing. The angle change velocity 0. Target velocity, they're actually just really similar. This is a memory set. Calculate the error to be, yeah, very, very small. The output is going to be, I guess, just like a short step in that direction. Okay, it basically just made it. So. These values. Yeah, that's not looking good already. That looks ridiculous already. Yeah, okay. That already I think doesn't make any sense. It's overshot it for some reason. So I don't know what this does, honestly. I just don't know what this does. Maybe I just take it out. Because in like literally a totally normal state, nothing crazy is happening. It's immediately overshot it by a crazy amount. And I say crazy amount because I mean in this like relative terms, it's just overshot it for some reason. This value seems excessive to me. This is like double the change that we just applied. And in fact, it did this from just a single value as well. $10 from the first one, double the negative from the next one, 10 from the last one. So 10, double the negative, 10. Maybe I'll just let it go one more step. So yeah, that is the same output as last time. A dramatic error this time. So the output's going to be add the present error times 1 plus that second error times a slightly larger value. So should, I think, just go to... It's just that it's the output plus, which is what gets me. Why is it the output plus? Why are we keeping track of the output? I mean, I guess this is like infinite impulse response, right? .21 minus 0.21. So is this really just supposed to be the acceleration then? Is it just always adding a time parameter? Is that kind of what this is supposed to be doing? I have an angle. So here's the angle that I want to be at. Here's my current displacement. Here's what I want displacement to be. But if I treat it as saying, here's my displacement, here's what my velocity should be, and then here's my velocity, what should my velocity change be? I guess that is the question, right? Because this would be the correct, this is like close to the correct output. My input's 0.21. My target's this, so I say, all right, let's subtract 0.21 from that input. Then I guess this part is just... yeah, this value is just, it just looks like it's exploding. It seems like instead of being a low pass filter, this is just creating reverberation. This is like adding a problem. I don't understand this term. I feel like this can't be correct. There's got to be a mistake here, right? As I said, it's exploding is what it's doing. Like, this is what I had before, add the filter, this is what I get now. It's saying, yeah, so whatever you're doing, double that. That doesn't seem like a filter. It seems like the filter's doing the opposite. It's causing problem. This one to me is just really suspicious too. These lines, I don't understand these lines at all. Like, how does that make any sense? What the hell? What is that? Am I actually looking at assembly? What is that? Mathematicians, man. What's B and A? Are some coefficients B and A? Okay. X is the input, Y is the output. And they decide both are going to be 2. Which I believe is what this one is. They're both 2. Coefficients. I guess the weird thing is that the coefficients are. I don't know what a Z transform is. I mean, the thing that gets me is I don't see any... They start doing this crazy stuff. Fun. I mean, it was all right there, but I can't understand any of that. It's too much. And it's not... It's also just different, too. Okay. Looking at what this is doing and just it's exploding no matter what. I have to put in such a small value for it to not explode. I'm convinced it just doesn't work. This implementation is just wrong in some way. So I'm just going to get rid of it and I'm not going to use it. What? What? Okay, no. What? What? I feel like it's not even hitting it. It's just... It's like instantly returning. Or am I crazy? I hit step over. Okay, delta is 0. Right. Okay. So nothing yet. Continue. Take it off. Continue. Okay. Input 0.004. 0004. Out. A target is 005. So what will we do? Memory reset. Compute my constants. Those are some values. KD is quite small, which makes A2 really large. Shift my errors. And then, yeah. Well, because A2 is very large, it makes the other ones quite large as well. So I end up doing a massive overcorrection. That's what I think I'm gonna see. Yeah, okay. So derivative is just too small. Derivatives should not be that small. We'll say 1. Looking at the exact same case again. Okay, so I made derivative larger and these numbers have completely exploded. What is wrong with derivative? Is it all just like screwed up? Because this is about to do, it's gonna go crazy again. It's gonna say 04 plus this number times 100. That doesn't make any sense. Why? Because derivative is just too large again. And if I set derivative to 0, this is going to do nothing. Well, this one will be different, but then derivative, it would be plus this, minus this. It doesn't seem right. What does this one do? Derivative is the change in error over delta time. And then I have a constant multiplies by that. Which in this case this would be a very small value, a value smaller than dt over that. So even if derivative was 2, this would kind of do like nothing, because this is small relative to that already. So it'd be fractional. Here, when dt is large, it kind of overtakes everything when the derivative is large. When derivative is large relative to delta, it takes over the entire system. It does. It takes over the system. So KD needs to be small relative to delta time. I wonder if this is just wrong. Or maybe it's just the case that I do need to make this a very small value because these values are going to change. These values change quickly. So this needs to be like relative to delta time. I don't know, maybe these were right. And it's just that delta time has to be ridiculously small. Or this needs to be small in comparison to this value. Must be it. I wonder if I should just take delta out of this division for KD entirely. That would make it more reasonable, because otherwise, like, I had to start with this being like this value, and then I need to make adjustments in that range. What's the point of... I guess KP is effective here as well. This part just seems odd, because it feels like it doesn't actually matter whatever I set KP to in this case. What matters is what I set I to. I mean, but I guess if that's the case, then like this term would do nothing if the prior error was 0. So I guess it still kind of kicks it off and does something. Right, so this will add like a full response, and then it will take off no nothing. So, I mean, yeah, it should just reach the error. And I guess it would overshoot it slightly because of this, but very slightly. Not even enough to really see. So now T is this, AD is that. Which in this case, because alpha is always used as itself over itself plus 1, the larger this value is, at least on this side, the larger AD is here, the smaller the effect it has. And pretty much the same case here. The larger AD is here, the smaller this term would be. So if it's 3, this is like 2 over 4. And this would be 3 over 4. So these are like fractional values. If AD is less than 1, then that would make this a very tiny value. That would make this a very large value. Well, I guess the maximum it could be is -1 over 1, which would just be -1. So in this case, it's going to be the errors again. -0.5, -1, and 0.5. So yeah, now it's going to be operating with like a half of the error. So this shouldn't really explode then. Yeah, the numbers all stayed 0. See the exact values. Yeah, that's a very small value. I mean, yeah, it's just half of that, and then the other term is slightly smaller than that. Or a number slightly closer to 0. So let's input this target, this is the new output. So now it just says, yeah, go for that one. I'm going to watch it run a few times. Okay. So something interesting has happened. We were essentially just trying to do nothing. Its new velocity comes out to be 0.21 and the target velocity is slightly high. So it's just going to be kind of different from last time because our last output was to be slightly negative, and now the response to that has been that. Okay. Input is 0.21. Our output would be negative 0.21. Yeah, our target's 0. Yeah, I forgot. Our target is 0. Input's 0.21. Output is negative 0.21. Is this correct right now? If it was to be an adjustment to the velocity, then this would be a fine value. But this is the velocity. So 4 has become a large value. That's become sort of whatever. And then we're going to add to that. Okay. Doesn't matter how I would use it. I mean, okay, I feel like the way that this is working, if I'm treating it in this way where I'm saying, here's a displacement, give me a displacement over time, and then I say, here's a displacement over time, give me a displacement over time squared. Right. But I don't know for sure. I want to look at one more run, because this is when it will become saturated. This is when the memory saturates. So our input is 0.29. Our target's now negative. Right. So these have a pretty, this trend makes sense of errors. So what do we want the output to be? I suppose this makes sense. Wait a second, am I providing it wrong? Yeah, target velocity is the input. Okay, this still seems right. it's sort of, at this point it's telling me that it's pretty much non-responsive, right? Like we need to respond harsher, right? It's spinning away from us. This value was a lot larger now. 100, not 100 times, but like, I don't know, a few more than 10, 20 times. It still feels like it could be an overcorrection. Whoops. I let it run without. Yeah, it's like it's running away. Yeah, this output just seems quite large, and it's not. Wait, what? Oh, it actually, okay, it actually passed. It actually passed it. Because the last time I said, okay, we're going too fast, we need to slow down. I missed it. Oh, well, this was the previous output, which feels dramatic because I think the last output was like, damn it. I missed like a very important thing that just happened because of that. I forgot to put the breakpoint. So I step. This is the point that it apparently flipped. No. Okay, I think it was one more. Okay, yeah. This is a point where like it got a response finally. And now the error flips. Yep. So yeah, that's kind of the crazy part. The last output was 0.04, and this one says to do what? To output 06. I mean, if this was actually a change of velocity, then it just keeps seeming like that's what it should be. Does that make sense then? Was given a velocity of 0.4, or whatever, 4. And then I was calculating a target of 5. I guess I'll find out. And whatever. I missed a step. Velocity is 0.3. Target is negative. So these values all still look the same. So this is our input, this is our target. Then I would expect to see a value smaller than input. It's just the opposite of the input. Alright, so this value is sort of exploding. I mean, I feel like those just do. Yeah, I don't get why those just do that. So it's target velocity. Actually, I guess in this case, if I add it, then that works out, right? I'm going to roughly end up with a... Let me try my target velocity. 0.012. That was negative 0.012, and now... What? Maybe I said 0.0 as in like 0.0. I'm going to say that's what I meant. That's what happened. I'm going to say that's what happened. I'm going to click on this one to see. Yeah, I think I definitely meant to say 0.12. So my target was 0.12 and my output is now going to be 0.13. Okay, so read my current velocity is a little bit high, it seems. So it looks like I kind of got the response that I wanted, but it seems like it went a little too far. Because I think that was the case. I said my target should be 0.42, and now my new value was 0.5. Yep. So now this is actually going to calculate a very small error. Is that small? Target minus input. Well, I guess it's more like the difference between this input and the previous output is kind of what I wanted to see. So now it seems like these values are going to stay. Feels like a bit of an overcorrection. Target velocity is that my output is going to be something kind of close. In that case, it actually was the case that it was 0012, right? Current velocity target, the magnitude of target has decreased, which is good. I like to see that stay relatively small. It's still dropping right now. I think there's like probably 10 or 15 frames that this takes to settle. So things are still kind of moving. So input is 03, target is a value near 0. So the error has changed sign, though its magnitude to the last one hasn't really changed. Seems fine so far. 0.1 is the change we want to apply. Which actually looks pretty good. That seems pretty good. Not really changed. Okay. Input is 03. Output is negative 05. Okay, so the current velocity is that's the target velocity. So I'm going to return like 0.02, negative 0.02. Or negative 0.01. Okay. Everything still seems pretty fine. Okay, velocity has changed a lot, it seems. So it looks like we have the opposite sign again. Though this value is now the smallest magnitude out of all of them. So an output is going to be O2. Smaller still. These values still seem reasonable. They're not increasing in magnitude, they've gotten smaller. They have changed sign, but as long as they're not, as long as I'm not going from negative 0.04 to positive 0.1 or negative 0.1. O381. Okay. Target is 0014. Zero zero two one. And I do believe this IK angle is small enough still that this is still effectively within a single IK step. So it's not drifting. It's not drifting. This has to get into, I think, centimeters before I can say, yeah, this is a drift. And it's staying really small. So this is what? 5 zeros followed by a 6 and negative? Now IK angle is what? 5 zeros followed by a 7 and positive. That's not the best. But it hasn't... This looks like an oscillation so far. A catastrophic oscillation, actually, because the value has gotten larger and has changed sign. Though, as long as these ones still kind of stay, these outputs stay non-explosive, then that's fine. Right, so the error changed sign again, but it's still a smaller value. Previous output was 0381. Staying small. This number is staying small. 381 to 245. Smaller value. Target is 0014. Zero zero 018. I feel like that was a negative value, wasn't it? IK angle is positive. That didn't seem right. Yeah, that didn't seem right. Yeah, this is okay, so this is maybe, I don't know. I guess I'll find out. So the angle, 5 zeros followed by a 7. Positive. Angle. Six zeros followed by a 5 positive. Well, that's just a magnitude lower immediately. So that's pretty nice. So then what? Okay, the magnitude, the error flip sign, but it is still a smaller value than the last positive. 00245. I think it was just 0245. So that's already, and I think it's gonna turn out to be the case that this one kind of wants to, it's gonna keep decelerating, but it's going to, like, you know, it's like a spring now. It actually looks like it's acting like a spring, or it's gonna slowly approach. It shoots past it and then it approaches slowly. Hopefully without, if it does overshoot, then hopefully by a much, much smaller value. Are these still small? These have gotten really small. Oh yeah, this is the previous value. Okay, I mean, it's gotten larger. Flipped sign. 253. So the target velocity is going to be slightly positive. Or no, the target velocity is actually going to be slightly negative. Or the output's going to be slightly negative. But the angle has dramatically decreased. 0041. 029. .0018. Okay, so it's changed sign and sort of increased. Still watching it though. The IK angle is still 6 zeros and a 5. So it hasn't really changed. Target is a very, very small negative value. The sign is flipped and it is yet again the smallest number. Well, the smallest number of these first 4, which is good. I want that number to slowly decrease. This value is still small in comparison. Input is 221, output is 181. Target velocity was effectively a 0. 6 zeros. 2 zeros and a 4. Five zeros and a 9. So magnitude has increased. Sign changed and yet still smaller. By a little bit. Okay, well I think this is just, seems like it's going really well. So I'm just gonna watch it run. Okay, but it does flip out because all the other legs just can't handle it. Okay. So then I would like to watch, let me check that the forces aren't. Yeah, so I think the angles are probably all going to be pretty good. In fact, I might just say the femur seems like it's done. It hasn't exploded itself off the start. Because technically it does start with an oscillation. It starts with a disturbance. And then while I was running, I didn't see them like suddenly fling out or flick or do anything like that. Yeah, so I'm gonna watch I guess the tibia. Let's see what that one's doing. Tibia part, good. And I guess it may be the case that it's still possible that this angle control has too large of a response on all of them. I guess that is still possible. Angle, target angle. Velocity is negative 7.1. Target velocity is negative 0.71055. So I'm just going to see what the acceleration gives me. Wow. Mm. Was this again the case that because of how... No, this one's just the normal one. That's ridiculous. Okay, so I'm going to say something definitely is exploding on that. That's too substantial of a response already. That response makes no sense. Velocity and target velocity, sure. That seems fine, but then this one definitely has exploded. So why do you explode? What makes you super mad? Derivative. Is a very large value. Yeah, okay. So again, it seems like it's just derivative is dominating the whole thing. Because this is like 0.010002, and then this is 100 times more powerful. So is it just the case that derivative needs to be scaled by delta? Because it really feels like that just means I should take delta out of the division here. But I suppose I shouldn't. It could just be the case that what I'm trying to think of. That my delta time steps are just too large. Or the time set this algorithm may be intended for, which is to be, because I think I'm technically running 10. Yeah, I'm technically running it as like a 10 millisecond loop. But then things are changing more on the order of like actual milliseconds or fractions of a millisecond in reality. Or I guess like if I were to treat physics as having a controller and I was reading in the input, I would say it doesn't have, it's not a short enough time span to really get feedback fast enough. Because it's like from one 10 millisecond to the next 10 millisecond, the error has dramatically changed. This just looks like, again, I need to make delta literally a tenth or a hundredth of the value that it is right now. Or a derivative. It needs to be way smaller. Immediately. Yeah, I don't like these values being that small. That doesn't seem right. I suppose if I think about like what, yeah, even if I think about it that way, if derivative is meant to like estimate a problem in the future, then it's effective. It'd be like I'm projecting a second in the future using a hundredth of a second worth of accuracy, which is kind of crazy. I should be projecting step to step based on some value. Okay, so in this case, I'm actually going to say here, 100%, drop the delta division in that case. Drop the delta. Here, I may do the same thing again. Because this overpowers it like crazy if this is much larger than delta time. So I'm going to do it again. I dropped that. Because I want to work on scales of like starting at 1 and then reducing or increasing if it seems too powerful. Here it's like at the start at the same value as delta time and then decrease or increase as I think I need to. And then I'm going to do it here again. Maybe. I'm not sure, because here is where this is something well, I suppose that just makes this effectively what this is doing is it's taking this and multiplying it by delta, and then taking this here. That's kind of what the result is. Because it's like A divided by B divided by C. Which is just, I think, the same thing as doing Let me double check that. I always have to click here. Simplify, switch to tab. I have the tab open right now. Let's do simplify A over B over C. A times C over B. A over B over C. A times C over this. Is that right? A times C divided by B. A times C divided by B. So if I treat the default here being 1, then that means this delta goes away and this becomes 1 over. Which really just means I take 1 over 2. It's like, I'm trying to make sure I do this right. Because if I want it to be relative to the delta and not in terms of, not even in terms of delta either. It's like 1 over the delta. Or it's more like this over the delta, yeah. Which is just kind of, I feel like that's an insane way to work with this. Maybe there's some situation where, I mean, I guess if, no, because if delta actually decreases, okay, it's more like the error and the output have to change very small relative to delta. The error is changing a magnitude over the delta. So delta is like 0.01. The change is like 1 or 0.1. And then the derivative just explodes the whole thing. Let me just write this. Okay, yeah. Alright, so if KD is like 1, then alpha becomes a very, very small value, which I would actually prefer that alpha stays a large value. That if KD is 0.01 in the same realm as delta time, then this value is more like 0.5. Otherwise, it'd be like 0.01 over 2, which is quite dramatic. So I think that just means I just take delta out of this term. And then I would take delta out of this term. And then I can drop this. This stuff. Whoops. Whoops. So derivative is now no longer has to be this ridiculous value. And I can leave it as 1, and 1 is going to be fine. 1 is not going to make things blow up. So relative to delta time, this would have been like 0.5. So I'll say 0.5. Okay. All right. So now, honestly, I'll just look at it. There's a shake, and I'm not really sure what this shake is. I was watching at normal speed. Can't really tell what's going on there. But I guess it's possible these are probably just way too high. Accelerations might be excessive. What is happening? Am I just blind? I don't see Tarsus part there. Yeah. Awesome. I'll flip this here and see. Okay, I mean it changed. Just want to see if these are all like the same setup. Okay. Yeah, you know, let me change these defaults. It's probably smart to start with like 1 and then... This one's always going to be like a very small overall change to everything. And then say 0.5. Because it feels like derivative can tend to have a dramatic impact on everything. And then all these defaults changed in real time, which is, I'm okay with that. Whoa. There's a weird kick back there. Okay. So the question is, what maybe needs to be changed here? I guess I don't know. I feel like the angles were kind of smooth at their values. So I feel like these can be higher and probably on the simpler. Okay. So I do sort of see that response though. It is kind of high. So then I would say, I guess at this point you would probably increase derivative. So I'll just try that. Though I don't know. Yeah, so I'm not really sure what the kick that happens is. Okay. Trying to get it to like do what I want it to do. It is toppling. Which is really weird right now. I feel like I don't understand why it's toppling like this. So I don't know why it's kicking like that. That's just ridiculous. Weird. Was that it? I left those as a large value for some reason. Yeah, I kind of don't get what's happening here. I do see them moving quite smoothly. They're staying at their targets. There's just these kicks that happen. And I think it's because one of them, like, just tries to accelerate like crazy. And that happens. Yeah, why does it do this? I don't quite get how this happens. Everything is pretty low, I think. I feel like I don't have anything that's excessive. And I think the only thing that can really do that is one of these. But how these values are like really small. And integral is also small. Integral is like a buildup of the error. This value is just too large, maybe. It's a total guess. What did I expect to see? I guess I just expected to see some stability when it's at the angle. And now it's sort of able to move with small ones, but I'm not going to be making small adjustments, right? I'm going to be fixing a point and saying, get close to this point and stay there for some time. Or I'm going to be saying, here's a point that's quite far away, travel to it, right? Okay. I'm going to go make food. I'll be back. And then the next thing now is going to be, well, I guess I can send it right now. Because I think I like where things are at. I'll probably just add everything. It tracked the renames of those files. Great. Because I barely changed them. Derivative is 1 over delta. Previous algorithm is dominated by the derivative term. Wait, let me check that if derivative is 0, that is not going to cause a problem. Okay, it's a problem. Zero is a problem there. Is it a problem here? No. Not a problem there, problem there. Wait, what? Like scrolling too fast. Not a problem for this to be 0. Not a problem for that to be 0. Then yeah, this being 0 is a problem. What would the previous thing do? If this was 0, then this term would be 0, and that would be a problem. Okay. So it was still an issue if this was 0. If it's 0, then that makes 4 be 0, which means 4 and 5 are always 0, so this is always 0. Minus something that's also guaranteed to be 0. Because initially this term will be 0. This term will be 0 because 4 is guaranteed to be 0. And then that guarantees 5 to always be 0 as well. So this whole thing is multiplied by 0. So that doesn't matter. And then because this is initially 0, this whole term doesn't matter either. So I can just do a simple check. If kitty is not 0, then I can do this. Otherwise, it's... everything is 0, we may as well skip it. And yet again, if this is a very small value, that makes this a very, very large value, which means this is basically equal to 1. This is basically equal to 1. These will all be small. So you can be like 2 small values added together times 1 minus effectively this term times 1. So it stays really small. Okay. Does not explode. Wait a second. I did forget about something, which is the fact that this is supposed to be an iterated system, and is supposed to incur errors from the other parts in the system. So when one motor has some velocity, I know for a fact that's going to cause an error on it's more like I read in that desired velocity, and from there I can say, given this velocity, because I think the issue is right now they don't have they don't get information about each other, I guess. And that's also where the delta would actually drop as well. I would want this to I mean, I guess the assumption is I can take the velocity of all the motors, assume that that is what's going to happen. Assume that's what will happen. Which means the error is going to be taking... I mean, I actually don't do any... I do a bunch of stuff and then don't do anything. Well, this part's important. I think the idea is probably that I say... Yeah, because ultimately it's just basing everything off the angles. And if I can estimate what the angles would be after, like, in a single iteration, then I can probably improve things. Though, that does cause an issue here, because essentially the loop is that I could use much smaller delta times. And then I think I'm supposed to be passing in I'm supposed to be computing an error as if this might be a way to actually stabilize it a lot just by doing 2 iterations. Or even just doing 1 with a good error term. The error would be the assumption that the velocities I've applied currently is what's going to happen, on top of a single step of their present velocities. So I might say Here's the current velocities. Here is where they will be if that velocity continues. So I want to correct for am I correcting for that? Did I just say that this would be like this times delta? I need to finish this first. Yeah, maybe it's like how does this work? Let me look for this. I can still just commit this before I get into it, but collisions creates the contact constraints, applies gravity, set up velocity constraints, islands, active constraints, step, islands, whatever, start step, whatever. Then we solve velocity constraints. Integrate velocity so it moves everything. Oh, the pre-integrate and then integrate. Post-integrate, whatever. I guess this does continuous collision detection. And then position. So for collision, does that like just add them to a list? Find collisions. Contact constraints. I guess what I was looking for is to see if it moves things and then does velocity and then does position. Or, well, I mean, yeah, obviously what it does velocity, then it moves, then it does position. I'm trying to think about that. So what the rotation error is a velocity change, which is just a pure subtraction. It just subtracts the error. I think then in that case what it should be is the parts use that error for joint velocity minus a rotation error, which is a calculated velocity error, I guess. But I guess I can do both. I can calculate, I can say, all right, we did that step. Now here's the angles. And now here's the velocity. Like I could calculate both. I think it's especially the case for like the tarsus and the tibia. If the tarsus is doing something, it's if the whatever the tarsus is doing, it's going to have an inverse impact on the tibia, and the same way around the other way. Whatever the tibia does will have an inverse impact on the tarsus. So it's kind of always to say, the tibia will have an error of, you know, whatever the mass distribution turns out to be. Tibia is going to have an error of that fraction of whatever the tarsus is doing. Okay, I'm gonna get food because I'm getting hungry. I've thought about it enough. Can I send this? Yep. I'll be back. I'm back. I've got food, and I'm going to eat. Right. I'll be back. I'm back. All right. Yep. Okay. I'm gonna add this one as its own thing. I don't even remember changing those, to be honest. Okay. So yeah, this is to fix 0 deltas, 0 derivatives. Actually, what is division by 0 and float? What is it, the ALUF? Should know what this is. Okay. The standard is infinity, negative infinity. Okay. So yeah, my comment is correct. Okay. So the rotation error, the part. Bone rotation axis vector. So this is what I use. This is what I would be using. Yeah, this is not even used in here. And there it is. So I use that to calculate the joint velocity. Here's what I'm going to do first. I want to provide this so that I should just pre-compute it, probably. Essentially, my issue is that every time I call calculate the velocity, it's effectively operating as if some it's more like this. The problem with calculating this and providing an error in this spot is that if I call this more than once, and technically this value hasn't changed or this value hasn't changed, then that's going to be a problem. So I need to call it with a delta that matches. I guess I also need to make sure that essentially it has to make progress. If it doesn't make progress, then those controllers are kind of just being lied to about what's really happening. Because otherwise it's going to say, all right, let's go for 0.1. And then it comes back with the exact same angle again and says, all right, do it again. And it's like, okay, well, I did 0.1 and literally nothing changed, so I need to do more than that. Because it's going to accumulate that error. It's going to accumulate the error. So I can call it more than once, but I think what I really should do is I would pass in a fractional delta. So I'm going to be looking for this, an iteration delta. I'm also concerned about some things probably exploding, like this. There's something up here where Hello,
How you doing?
Byra. Hello. Thanks for raid. Thanks for the raid. Hello, Rick Dev. I recognize that name. I am just reading Wikipedia right now. Hope streams have been good. Yeah, they've been good. How about you? How was your stream? What were you doing? Same was good. Nice. PID is nice. Yep. Crawlbot, I struggled with crawler enemy recently. Really? That's interesting. Are you doing 3D or what? I'm modeling a full, like, joints and motors and things like that on these legs. And I'm investigating just how, like, engineers would do this. So, to hopefully get something that doesn't just explode whenever it has to do a small movement. 2D should be easy and simple, one would think. I mean, I guess at least in the 2D case, there's a lot less variation of things. Especially for rotation. You have one axis of rotation in 2D. In 3D, that basically just explodes to infinity. Or at the very least, 3. Now I forgot what I was actually looking for. It was... It's what I should do if I restrict. Because it's the case that if the acceleration, I guess. Because it's definitely the case that if it is constantly being prevented from well, I guess the Hang on. I think that might only apply here, where this one is just continuously updated. But on any of these, this is just a track of that, though this incorporates the buildup actually. And I kind of saw it earlier where when the derivative term was just, even just a normal value was too high, it would build up significantly. And then when I corrected it, it would just be stuck at outputting like 500 for the next minute as it slowly decays down. So I think I need somehow I mean, probably what it is I just need to trim the output. So I can obtain the output and then I can override the output. In this case, integral is maintained over time. So how would I fix that? I guess I can't. Yeah, because in this case, integral can't go away until error flips sign. And then it would go away. But while it has an error, this is going to keep building up. So, like the case that I walk up to the leg and I restrict the leg from moving that way, that integral is just going to keep growing. It's going to grow really, really fast. Until it dominates the term, and then I step away and it whips forward at maximum velocity. Or anything. do anything about it? Can I really not? I could possibly... I was going to say, if I change the output... from the error, I have the error and I have the integral. So the integral is the thing that I want to reduce. Integral is determined by the error in delta. I was going to say I could work backwards, where I keep the other two things fixed. I mean, technically I can... Actually, I can. Knowing the output... knowing what the output was, and what I want it to be, I already have the error, because it's stored there, so I can recalculate this term. I know this term. And I know this side, so I can use that to calculate what derivative must have been. And then I can change the output for the new output, and from there determine what this should be. Yeah. Do I need to be able to get the output? I don't think I need to be able to get the output. Well, I was going to say that I know what the last output was, but I guess I don't actually know what the last output was. But I can store it. Yeah, let me just store it. I only need that for this one. Okay. So I know what integral was. I know what error was. So I can say I'm just gonna reorganize it here. I mean, honestly, if I'm gonna store it, if I'm gonna have it, I may as well store it, right? Instead of just going through to calculate it again. Well, I don't know. The only reason I'm storing last output is because okay, it's more like I'm just figuring out what integrals should be changed to. So yeah, still leave it as 3. These lines will stay the same. I'll just keep the derivative. What's wrong with this? Oh. Okay, but this is going to be instead, drop that. Times the new integral. This was error 1. Okay. So I will just subtract these. I will flip. And then I would divide by ki. Which requires that ki be non-zero. do that. Hey Sam player, how's your robotic spider? Slowly improving, I think. Slowly improving. So I calculate. Yep. Yeah, otherwise it's just setting output to these values. Let's say this. Yeah. Yeah. What skin are you going to put on it next? I don't have any plans right now for that. So this target velocity has to be limited. I do need to limit this. Just go and save it. That's just a lot of typing the same thing over and over again. The skin really suits watchdogs too. What do you mean that skin? The red and blue rectangle with a Z fighting purple legs. Clamp that, and then I will say pretend like that was your output. I get the acceleration, and then I say I do that, and then I run this, I calculate a new acceleration. Or I guess I recalculate it. And I return target. Okay. So my idea is that I'm going to this is it. It does not have that many segments, for sure. I don't know yet exactly what it's going to look like. I just am trying to get the legs. I think it's roughly at least going to have this skeleton, I think. For at least for this size, I'm going to make 2 more sizes of this. At least a smaller size, I think. Or a bigger size, I don't know. One of the two. Okay. Is this correct? Target velocity equals velocity plus acceleration. Acceleration would be equal to, yeah, target minus velocity. Okay, good. So then I will stand here. And then velocity is essentially 0. I'll go and look at what motor controller thinks is going on. Good. The values are not insane. So if I were to run this again with that off and stand in front of it. Whoa. Interesting. Well, I don't know. That's a odd description for that. And yeah, I looked at it. Why? Why? I was expecting this. Well, okay, so the angle is already being limited. Angle is still being limited. The motor, though, this is not what I expected to see. Yeah, it doesn't seem right. I was expecting to see a very large value here because this keeps adding up. And I'm looking at it and Is it actually commented out? It is. Looks like a Minecraft spider. Does it also weave spider webs? No, it's not a spider. I'm not making a spider. This has 6 legs, and it's a robot. So it's more like an ant. This is not doing what I thought it might do. All right, what if I overextend it? Okay, there we go. That's a large value. That value is crazy. Right. Yes, the acceleration of a single thing is that. That's way too much to try and accelerate by. So now I would do that again. It's also not pushing me as much. I can tell. Okay, that's actually a large value still. Really? Well, I guess I actually don't limit the acceleration then. Can this be a real version? I'm not making a real robot. Though I am going to simulate it as if I was writing as if I was to make a real robot. Alright, maybe I need to go back to having the velocity, the max acceleration. I should probably go back to that. Because otherwise this clamp doesn't really work. Whoa. Is there no financial benefit? No. There is, or yes, there is no financial benefit to making a real one. That is too many legs. Two segments, 2 legs, maybe 3 legs. Boston Dynamics, they have, I think, a hinge and a rotation. So their like advanced robot is 2 segments, but their I guess their hip joint has 2 degrees of freedom. It can rotate and I don't know, it can do this and then twist or whatever. And then their dog is 2 segments, a hinge, and and that's really just for stability. 4 legs is easier to stabilize than 2, but 2 legs is definitely preferred. This is all because of interest. I am making a game to sell the game. Your questions are a bit in a weird order. If you were asking the financial benefit of making a game, there is. That is my purpose. To make a game that is good. And then to sell that good game. I'm trying to be very careful about the words there. I want to make a good game first, because I think a good game will sell. As opposed to I'm making a game because I think I can make a game that can sell. And this is the most difficult, definitely, part of the game that I'm making first. I don't need to make good money. I want to make a good game. I want someone to play it and think that their time has not been wasted. And think that they would not have spent it doing anything else. That's the ideal. Non-existent function. On pose finalized. So now it's just lying to me. Why? No. Won't be doing that. No, I forgot what I was doing. I am adding a limit the acceleration. I'll try 360 as well. There's that. There. Jeez, I don't even know. What's like 4 rotations? And then I know what 2 is. Money comes to you like a rock star. What? You talking about... Is the song just called Rockstar? I can't remember. From Shrek. Thinking about the Shrek. The Shrek song. Yeah, I'll just say that. Okay, well, it's more like I limit this, and then I just do it twice. Well, if I do this, and then I take this, and then I limit this, this value is probably safe to use. And then just return velocity plus acceleration. Yeah. The famous game company. Okay. Would I do it if I had money? Would you buy yourself a yellow 2018 Chevrolet Camaro? No. The question is more of, would I blow my money on something expensive? No. Would I spend money on something I think was a good value and looked cool? Sure. I'm not the kind of person to look at a price tag and think, oh, that means good. This is $1, this is $2, I should buy the $2 thing. Nope. Okay, so max acceleration is supposed to be multiplied by delta. That would be smart to do. Get rid of that. Oh, jeez. Alright, whatever you say. Just want to see what the value is, what the value is at. I mean, I know that it's corrected. So then I get this value. Is that? I guess it is correct. Really? I feel like it should be... Like it should have been more than that. Ground velocity 0.8, target $1, $2. Yes. The people who get convinced that more money equals better and don't ask questions. Huh. What's the errors? Okay, well, I can't like I don't seem to be able to demonstrate it, but I'm sure that this is an improvement. Especially in that case, because every time so far when I walk away, it slings back pretty hard. Okay, and now it's kind of in a gonna ignore that. Dude, I'm not. I can definitely say I can't sell this for $2. I've already spent so much time on it, even though there's kind of nothing there yet. I've already spent too much time for it to be $2. And at least in the case of a healthy marketplace where prices stay reasonable, there is a thing to be said about what you're getting depending on the price of the game. If I see a 99-cent game, I'm going to say, all right, this is probably going to be entertaining for like maybe an hour. If I see a $10 game, I'm going to expect a little bit more. Right? If it's $60, I'm expecting I can play this for like the next couple months and then come back to it over the next years and continue to enjoy it. I feel like I might be. Well, I think I need this. I think I really do need this. I need the acceleration. I need to reapply the outputs. Because that's just stabilization of it. And I saw it right away too. I stepped away and it didn't shoot off. It kind of stayed where it was and then started coming back. And then that. Are you a good boy? Are you a Christian? I am Catholic. But not really practicing, more like raised. But that's not to say that I disagree. Or that I don't believe. Alright. Can send that. My English is at elementary school. I didn't understand. What did you say you are? I am Catholic. What did he say? I don't know. I answered your question. I was just providing a little bit more nuance about that. Did I have... Wait, I did everything right. Yes. Did I send that? Yes. All right. Here. I need to actually produce an error. I think the error can be the current velocities of its neighbor joints as a rotation error. But I remember I said before I can call this, it still needs to make some progress. So this will be corrected by the... No. Yes. No. What? The errors can change, but if I'm really to do it, I need to actually perform a step and say, all right, we pretended to apply that. Now here's the result. Now what do you want to do? That's it. I don't know. I'm drunk. Okay. And then actual joint velocity. Man. All right, how about this? I need something that I can fix in place. The target angle this is the thing that is fixed in place. This is what I am approaching. Wait. No, I just realized. Technically, if I'm iterating and simulating some errors, what these outputs are going to do is that they're essentially going to say, oh, hey, we're done, and then try to do nothing. and pretend like that's it. That's not what I'm trying to do. I'm going until tomorrow. God bless. Or in other words, does that even say anything? There's like 2 letters. I don't know what the letters are. I don't actually think that's anything. You just typed a bunch of zeros and ones. That is, I don't know. What is that? Well, now you're gonna make me check. Because I don't remember where ASCII starts. Is it this? Yeah. Yeah, I got it. I figured it out. The Y threw me off. The Y threw me off. I thought ASCII was always a 0, 1, 1, and then a 0. I guess just the last... Actually, yeah, what is the last character then? But yeah, like the last 7 letters then. I was way off. Last 11 letters. I don't know how I counted 7. What can I do there? Okay, they say like feed forward. Like I calculate it and then I would use this to correct for any errors. Which means I use calculate velocity on an IK angle and a velocity that I'm pretty sure is going to be good. Like these are the values that I think that I want it to solve for. So this angle would be small and this would be, well, I don't know. I give it a velocity that I think is... What? What? Solve for the error after that. Huh? I need to see this again. Set point weight. What? Using Wokepedia instead of Grokpedia, Conservapedia, and FanWiki. Wokepedia. What are they talking about here? It is beneficial to take the desired instantaneous acceleration, scale that value appropriately, and add it to the output of the PID velocity loop controller. Ah, okay, now that I say it out loud, I understand. All right. I go ahead and I calculate what I want it to be. And then I multiply it by some value less than 1. And then I say, hey, physical controller, give me what you think I should do. I add them together. So this means the PID has to do less work. And yeah. Though technically it's, I mean, I guess it could be fine. I guess think about what the concept of it is, that it is taking the errors as a history, a short-term history, and it knows from that it essentially is gauging the response. In my mind is what it's doing. I say in my mind. That is what it does. It effectively uses the history to gauge the response, to calculate what is going to happen in the future, and account for that. So the integral builds up, the derivative is just the change in errors. So essentially it means if this was 0 and this was some value, this would be a negative value to say, hey, whatever we did last time, we can stop doing that because what we did last time was perfect. That's kind of what this is. This one is saying, hey, I've had a problem for a long time. We need to just like start adjusting for that now. And this is saying, all right, here's what the error is. This is just the standard response for it. So, and these are just doing the same thing. They're just doing it in a with a bit more history involved. Are you going to use GD Studio? What is that? What is GD Studio? The one thing that bothers me about it using this feed, about doing the feed forward, is that I don't quite see how it is helpful unless I kind of pretend like I've already applied it. I mean, in this case, in like a physical system, that is the idea. I would have my system that computes some value, it does the thing, and then this comes in here and says, all right, let's do another thing to fix for that. But what this is also kind of saying is instead of doing all of that, I say, here's what I want to do, the PID, here's what it wants to do, I add them together, and then I do that thing. Would I scale both? Scale that value appropriately and add it to the output of the PID velocity loop controller. A proportional amount of force is commanded regardless of the feedback value. PID loop in this situation uses the feedback information to change the combined output. The what? Yeah. Godot, but less gay. What does that mean? Is it the same engine? Godot editor with a room for your game. I don't get it. Is that background actually moving? Oh wow, it is. Why is it? Where's the script? Here we go. Literally shaders. Crazy. I'm looking at the millisecond response on OBS to see how taxing this is on this computer. That's a whole millisecond, man. That's kind of crazy. They need to frame limit that nebula, especially with how slow it's moving. This could be updating every This could be... I can hear my fan spinning. God. Some people just don't know what they're doing. Already not a good sign. They don't know how to make a website. It's like a millisecond and a half, actually. I'm like 2.1, and then I go up to 3.8. It's like almost 2 milliseconds having this web page open. That's crazy. What are they doing? Who cares? Dude, this is a web page. They're killing my computer. My fans are spinning so much. That's stupid. They don't have a frame limit on this. That's literally like nearly 2 milliseconds to look at this web page. I'm not lying. This background is nearly double what is almost the same impact as streaming. My God, I can't believe it. I actually can't believe it. That actually makes me mad. Don't do this, please. At least fucking frame limit it. 30 FPS. Like, I don't see... I mean, let me see. I don't know. Maybe there is. No, they're just drawing as fast as possible. There's no limit on that. God. GPU control panel. I don't actually know what the FPS is running at. I think the default is 60, but I don't believe that that's 60. Unless this shader is actually just way worse than it appears. Which it might actually be, because it's doing like 4 hashes. Oh, and it's computing noise 5 times per pixel. That also has an effect, I think. Oh, and then it computes noise 3 more times. It's computing noise 8 times per pixel. Never mind. They're doing that way more. Can we be serious? No, I can't take them seriously. They are not seriously trying to make an editor for Godot, and they don't even realize what they're doing to a browser. With effectively what could be a static background. Why not open source? No, this guy needs to stop what he's doing right now. Also, this is kind of incriminating. I'm not gonna lie. This comment here is pretty incriminating. Replace with your Ko-Fi page URL. A little bit. Yeah, these comments are highly sus. Highly sus comments. Also, 2 milliseconds for a web page. Dude, stop. Stop. You can't be serious. It moves so slowly. You may as well just render a single frame and just let that be the background. Dan, I need you to go. No, I'm not going to say that. I was going to say I need you to go bother that person. But you can't. If you're going to do anything and keep it private and sell it, just make a game engine. Don't make a new editor for Godot. That's such a waste of your time. Especially if you're going to be using AI to write the whole thing. Don't do that. Such a waste of your time. I'm very distracted. I still don't know what to do about this. I want to get iteration in there. Because I don't think it should ever be... It's definitely still the... Okay. The feed forward is probably the best way to go. I use my iteration to calculate instantaneous changes, and then I use... Once that is done, on the last iteration, I take that value I calculated, I scale it slightly, and then I scale it down slightly, and then I run this using using the real values, I guess. And it's probably meant to like as like a balance point as well, where I say use 50% this one, 50% this one. Or maybe it really would be okay, let me read this one specifically then. The three types of control system: open loop control. Input and disturbance operates on the system to produce an output. Feed forward. A disturbance is taken into feed forward, which calculates, sums it to the input, and the system operates on that. What? This diagram is confusing. Feedback, closed loop. Yeah, I mean, it's just confusing. These diagrams just suck anyway. This diagram scheme is just not, does not work with my program mind. Applies an additional input to minimize the effect of the disturbance. Okay. So I do have known disturbance, particularly with, I guess there's two kinds. There's the inherent disturbance, which is just another joint operating against one joint, and then there's the exceptional disturbance, which is like an impact or me pushing into the thing. I guess external was a better word for that. So I mean, I suppose this is like correct then, isn't it? This is technically feed forward. Doesn't matter which way I apply it in. And this would maybe be multiplied by something. But I use this one to calculate something, and then I use this one. This is my... This is what I think should be done. But again, I just feel like it's kind of not set up the right way. Additional term for the motor velocity. Yeah. Let's monitor the pressure so that the valve only opens enough to cause the correct pressure to reach. Feed forward with the output of the system. In direction of travel, the vehicle plays no part in the system. Feedback. Observing the direction of travel, compensating for errors by turning the steering wheel. What? Feed forward control just goes into applications and it talks about what? Applications in nature. Nature has implemented the feed forward system. It's the fact that this disturbance arrow is pointing to the system is what I don't understand. Okay. Um, I'm just trying to think about. I think the biggest issue is the swing that's happening, and I keep coming back to it and thinking about it. So when this part, if this leg is lifted in the air and it's totally still, if this thing goes to move this way, this part's going to lag behind and then it's going to snap in. But then it's going to have inertia now and it's going to pull the whole thing forward. In that case, what does this femur do to stop that from happening? What can the femur do to stop that from happening? Can it do anything at all? I feel like it must be able to do something. One thing it could do is just reduce how much it turns by or how fast it accelerates so that it doesn't end up creating that deflection. And then when it stops, it would be stopping in time with it. Or is it that this rotates over here, this is snapping in, and then like for 1 bit, it comes back over here and then rides the inertia back and then also stops in that case. Can that even be, I mean, it can definitely be programmed, but like, is that easy to program? Is it as easy as just calculating and saying, hey, we have rotation caused by this thing moving, and so you need to account for that? And how does that account for it? So I feel like the naive approach is just, it will overcompensate it and cause it to be even worse. So it would move here and say, okay, but I'm actually going to only move this far, so I need to move harder over here to move that far. And then it's going to update and say, okay, now I have this huge rotation bringing me backwards. So now what I need to do is I need to move even further, so that when this pulls me backwards, I'll be in place. But then this thing is still moving, and maybe on the next frame it is all lined up. But it still says, okay, I still have a huge inertia going that way, so now I need to go this way. Oh, maybe that does correct for it. Because it would read this is going to happen, so then it goes this direction some amount to correct for that. And then they both equalize, and now this one's over here. And it's still pulling, but a little bit less, so then it goes a little bit more that way. Maybe that does. Maybe that is the right way to go then. Because now that seems to make sense. Because it's more like it says, hey, we're not moving. This thing is moving. I need to go this way. Which is sort of handled for here, where I calculate that angular velocity. So it does at least know that it's there. Maybe I just try this for now. There's base velocity. And maybe I have a constant here that is like I use half of my velocity and half of what this one wants to use. here. The target velocity is passed in, which includes this base value. And maybe that's all I give it. So maybe I see what this. What? Take a step. Do something. Do something? What? It's not lifting the leg, which is odd. It won't lift the leg. Why won't it do that? Why does it not lift the leg? It should be. Huh? One. What? 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 I didn't do anything. I haven't done anything. Now I'm really confused. What have I done? It's just not doing anything. You know really what did I change? I changed nothing. And now it doesn't work. It won't lift at all. What? Okay, there we go. Why is it, like, stable? That's what I don't get. Every time I started this, it's, like, wobbly all over the place. Excuse me? What is going on? Okay, no, like, really, what have I changed? This is the weirdest thing ever. This was the last thing I changed, and it was still being normal. Like, what's happening here right now? Very confused. Zeros. What? I didn't change anything. I don't understand. Nothing is different. And it's just behaving very, very differently now. I feel like I'm just being lied to. I just feel like it. Something is running some code that's like not correct. May have something to do with the fact that I keep getting these weird errors when I click back and forth. What is going on? It just sits here perfectly still and does nothing. For a long time. How is this breakpoint not hitting, by the way? That breakpoint was there the whole time. I was not hitting. Godot really is something. Like, I don't see values that make any sense. I don't believe that this is suddenly like perfectly stable. But it also just refuses to travel to this angle for some reason. Because suddenly everything moves by a lot. Everything moves. Are these building up at all? That isn't. Not really. Not really. Because it's more like the 4, 5, the 6, and 7 are 0. So to me that means it's not actually doing anything. And that's even less. They're moving? Well, this is the femur, so I shouldn't really see anything. Yeah, I don't know. These don't look like anything. It's like they all come up abruptly. I can actually see this changing in real time. Whoops. Why is memory set on? Oh, because it's because PID doesn't clear that one. What is going on? It can't lift. Is it just saying to do nothing? Nan? What the hell? Nan. It returned a Nan. Integral is Nan after doing what? Oh, what? This is happening? Output is Nan. Wait, what? Huh? Base velocity Nan. I'm gonna freaking... Okay, calculate velocity with a delta of 0. You know, I just kind of, I think I can't do anything here when delta is 0, so how about we don't do that? How about we don't do any of this when delta is 0? Okay, so where does it come from when delta is 0? Who's the problem? Cached delta. Okay. On pose finalized. All right. Cached delta. Process modification with delta. Alright, here's what I'd like to do. I'd like to just not do any of this when delta is 0. So, how about that? How about I say I will do nothing if delta is 0. I will not do anything when delta is 0. And then this is used down here in pose finalized. And I'm going to do the same thing again. Don't do anything. Oh man, sorry, I wasn't looking at chat. What up, Unk? Hey, Serpent. Did 81 streams on the crawl about? Yes. I have. Or I guess this is 80. You're in Hyperland? Yes, I am. There's just been a lot more here than I thought that there was for this. Alright. It is a movie now. I'm so annoyed by that. Alright, do your normal thing without any help. This is still weird. This is still really weird. That it's doing nothing. Which I think it means that there's still a problem. It should be like bobbing up and down or whatever it's been doing up until just now. Really, this said to not do acceleration at all? Huh? What? This said to do no acceleration at all. I want to double the velocity and it says don't do anything. Crazy. Target velocity 0, 0. What? Wait. Did I just change something here? I might be out of it now. Target velocity. Calculate it. Clamp. Apply. Now, given that, calculate acceleration. True velocity to target velocity. Calculates the acceleration. I don't get it. Three zeros and a 2. Wait, huh? Wait, what? Where did I see 0, 4? Okay, maybe I just don't know. Maybe I just don't know. Zero, 3, 8. And my current velocity is 3 zeros and a 7. So this should be something big. And it's kind of excessive, actually. It actually seems like it's really excessive. Wait, no. I'm looking at max still. Never mind. Incoming velocity, that. Target velocity, that. Acceleration should be that. Seems reasonable. So I said I would like to be at... Oh, I guess I overrode it. Base velocity is 169. Target is 3 zeros and a 4. What is going on? Wait, I'm looking at the wrong things again. Am I? Am I crazy? Though it is weird that the velocity should be this, and then I calculate to take it further from target. What? Why take it further from target? Three zeros and a 2. 3 zeros and a 4. How did you calculate? No, the error is correct. How does it? How do you calculate that? What? That's just nonsense. Target velocity, 3 zeros and a 4. Present velocity, 3 zeros and a 2. I'm going to follow this to see how it is possibly just calculating a crazy response. That makes no sense. So input is O2, target is that. What? It wants to go to 0. It wants to move away from target. That doesn't make any sense. How does that make any sense? Okay. Should I be setting this down here at the bottom? Maybe I should be. All right. Why does that happen? Is that really? Because I did this? That change? What? What's happening? Why is it weird? Why is it different? Why is it different? I haven't changed anything. I didn't change a thing. Why is it different? Nothing has changed. And yet it's different. Like, this was the main commit that I did. Well, I did this, but I was running with this. I was testing this one. I was running that one. Because this is even where I added this. So, I didn't... This commit was good. And then I did this, but I was running with this, and I was like, oh yeah, everything looks good, and I can't, like, find a way to break it. So, what happened? Was that it? I had this, like, I had like a nan in there, and I never noticed it? That's been happening this whole time? Why does that happen? Why does it... Why does setting the target velocity on there change it so much as well? That makes it super different. I'm disturbed. This is just the same code. It's literally just the same code. Why is it different? And why wasn't that happening before either? I've been running with Nan this whole time and I never noticed it? I don't believe it. Let me undo the fixes that apparently have broken it. And then I just run this. That's broken. So then what? There's nothing else. This has been how the codes have been running the whole time. There is nothing else. I guess I take these out and I see what that is. so odd. So this is wrong. Also, that this I don't believe it. I am now extra disturbed because this is it like, huh? Is it the Nan? Oh, it is. And then there's just that pop. But it doesn't matter. Let me try this. Instantly hit it. It just amplified like crazy. Okay. This is the error history. We had an error of 0.08, then we had an error of 0.1, and then we had an error of 0.12 in the negative direction. I mean, I suppose this on its own isn't so bad, but that is excessive. Is it correct for me to be using this as acceleration? What is that? Frame 1. Literally frame 1. Present velocity is this. Target velocity is this. Is this really going to hit everything? Okay. Don't do that anymore. Just run it. Like, every leg just lifts off the ground. Why does it do that? It's like fine, it's fine, it's fine, it's fine, it's fine. And then everything lifts. And they all fly out. And they all get marked uncomfortable and then they all lift. So what if I did this? I don't get it. I don't get why it's suddenly such a different thing is happening now. When I had to run this before. Especially with that happening. And I don't know how I can go about debugging that. Really, nothing hit the max velocity there. But I hit the maximum acceleration constantly. This is insane. It is. This is a femur. No, O2. We're currently rotating a degree per second, and then we want to rotate 4 degrees per second. There's just no way this isn't like an over. It can't be literally doing it all the time. Okay. I don't know what's happened. I'm very disturbed by this. That I was hitting run several times. I wasn't touching the code. At least I don't think I was. And then it worked. And then I come back here and then I have nans are showing up and it's not doing anything. And then I fix that. And now it has a completely different response. It's a completely different response. It's not like doing this where it's like bobbing in place. It looks like it does nothing, and then all the legs lift off, and then it starts bobbing around and freaking out. No matter what I do with it. I was using normal settings before. Like just all these first ones were all just default, I think. When did I change the defaults? Wasn't here. Oh wait, no, it could have been here. I guess I changed it when I made it, but I don't... What? Okay, that's it for today. I've gone way over the time. I don't get it. I just don't get it, because I feel like I've been doing nothing, and then I run it, and I'm like, cool, that looks the same. And then it stopped doing everything. Hey, QRT42, how's it walking going? I'm quite annoyed. It feels like it just totally changed the way it was working, and I haven't changed any code. Like either there was a bug that I was getting the entire time and it somehow wasn't bugged when I was actually running it, and then suddenly it started to become bugged. I don't know. Because I swear I did like 4 commits in a row where I ran it every time and I didn't really change anything and it still had the same look. And I'm like, oh, now there's a nan here. And then I fixed that and then it doesn't do anything. Or no, it started doing nothing and then there was a nan I fixed and then it's still was like doing nothing and then it would, I don't know. I'm over my time though. I'm done for today. Really unfortunate timing to come right at the very end of it. Yeah, I gotta go. So thanks for watching. I'll be back tomorrow. Goodbye.